Now let's take a look at detecting objects using the ultrasonic sensor. So at this point we have the task bot and we've attached the ultrasonic sensor and the light sensor to it. And make sure that you attach the ultrasonic sensor to port 1 and the light sensor to port 2 just to match what I'm doing on my robot. And what we want to do here is just to write a simple program that will play a high-pitched tone anytime an object is detected within, let's say, 20 centimeters of the ultrasonic sensor. And to verify that our program is operating correctly, let's play a low-pitched note when the object is not within 20 centimeters. So we do this so that we can kind of sense what's going on with the program when the ultrasonic sensor sees something, when it doesn't see something. And the rationale for doing this is to first gain experience setting up the ultrasonic sensor, because there's a variety of settings that we want to do, and then also just looking at another Mindstorms block, which is the sound. And sound can be very powerful when you're trying to create and debug a program, because a lot of times if you create a complex program, the robot, you'll run it and the robot won't do anything, won't react. And so without seeing motion on there, there's no way to know where the program is. And so inserting these sound blocks in there is it's a really powerful way to kind of walk through what's happening with the robot. So let's go ahead and start the LEGO Mindstorm software. And what we're going to do here is I have my task bot, as you can see, and I've added the ultrasonic sensor and the light sensor. And what we're going to do here is let's just create a new program. Let's call it object 1, and let's go ahead and say go. Okay. Now the first thing that we want to do is let's go ahead and put our switch statement down. Now we know we'll put this in a loop, but for now let's just go ahead and put this down and let's set it up. This is going to be how we set up the ultrasonic sensor. So we come down to the control. Make sure that you have the switch selected. The switch represents the decision. And I'm going to come down here, and under control you have sensor or value. We're going to leave it at sensor. And then instead of the touch sensor, change it to ultrasonic sensor. And then over here on port, the default comes into port 4. Go ahead and change that to port 1. And then what we're going to do is, this is when it's going to return a true when by default it's less than 50 inches. Now that's really far away, so what we want to do is we want to go ahead and change that. So let's make that 20, and then come down here into centimeters. Make sure that, notice that when you change it to centimeters, it converted the value from what it was in inches. So go ahead and re-enter 20. So what this is going to do, notice that when you come back up to the switch, you see this logic 1. That represents when it's true. So when this condition is true, when a object is detected within 20 centimeters of the ultrasonic sensor. So it's sending out ultrasonic pulse, and then it's looking for a reflection off of an object that returns to it within a certain amount of time. Okay, so now what we're going to do is let's just play a tone when we see that. So we're going to introduce this new block. So come out here and into the common and go ahead and grab a sound. And what we're going to do is let's pop that in, and this will represent what the robot will do when this is true. So if you click on the sound, you'll notice that you have a variety of different things down here. You can play a sound file, and the NXT has a bunch of canned ones that are provided to you, with the software. What we want to do is let's go ahead and put tone on here, and it has a bunch of different tones down here, so we can see, high pitch, low pitch. Let's go ahead and put something pretty high up here, like a D, and then we'll go ahead and leave it at 0.5 seconds and this wait for completion. I'm going to leave that on just to show you what it's going to do. Eventually we'll want to turn that off, but I just want to show you what's going to happen when we do that. Okay, so then I'm going to go ahead and I'm just going to copy and paste this block, and let's drag this into the path where you don't see the object. So on this one, all I'm going to change is I'm going to bring this down and make a low pitch sound. So let's do a G for 0.5. Okay, so now if I run this, it'll only run once, and you'll hear a tiny little tone go. So what I want to do is I want to run this indefinitely. So I'll come up to common, and I'm going to grab my loop structure, and I'll go ahead and pop that at the beginning, and then I copy my switch and pull that inside of it. So at this point, we're ready to go. So let's go ahead and power on the NXT. And I will plug in my USB cable, and now I'm going to go ahead and I'm going to download to it, and I'm going to download and play. It doesn't have any motion, so it's not going to take off. Okay, so now it's running, and it's playing our low-pitched tone. And let's take a look. I'm going to move my hand closer to it, and look at what happens when I get close to it. Let me put the task back like this so you can see it. So I'm going to get closer and closer, and once I get within 20 centimeters, it will change the tone. Okay, so here we go, coming in, and you can hear the high-pitched noise. One of the things that you notice is that it's going 0.5 seconds on, and then it's kind of clicking. It's going tick, 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 and that's because what's happening, let me stop that really quick. What's happening is that it's running through this loop, and it's doing the tone for 0.5 seconds, and then it comes out of the loop. Okay, so one of the things you can do to make that work a little bit better is go ahead and go into these sound blocks, and I'm going to, let's play it for just a short amount of time, 0.1, so that it's not just sitting in the sound block for that amount of time. You kind of want to have it move along. So I'll change it to 0.1, and we'll see what that does. So now it's really moving, and I can come in with my hand. One of the things that's really interesting is that this ultrasonic pulse, it needs to bounce off of something. So it is absolutely possible that if it reflects off of your hand and your hand's at an angle, it can go off in a different direction. So that's why like a book or a phone is a flat surface is a really good way to reflect something. A coffee cup is something I always use to do obstacle avoidance, but it turns out a coffee cup is really it's really one of the harder shapes to detect because it's got a round surface, and what happens is that the sound reflects off in all directions, and so a flat surface like a book or a block is something that is a good way to do that. Okay, so anyway, the thing's running, but it's still clicking. Okay, so what we want to do now is I'm going to go ahead and stop it, and what you do to get rid of that is you come in here and you say I'm not going to wait for completion. And so what that does on these sound blocks is it will just play the tone and continue through the loop, and that way it'll go it doesn't just hang in here. And you don't usually want to write a program where you're stuck in a particular block for very long. You want to kind of cruise through them and get back into the looping structure. So let's see how this is going to work. Okay, so now I have a continuous tone, and when I bring my hand in, I'll use a phone here, it's a little bit easier. Okay, so see how that flat surface is it detects it a lot easier. Now notice when I do it with my hand, it's not quite as good, and it's because my hand is reflecting the sound in different directions. You can actually see that when you turn the phone. If I turn it at an angle, it doesn't see it, and it's because the sound pulse is bouncing off at an angle and not coming back. But if I turn it completely orthogonal to the wavefront, it comes right in there, and if I turn it this way, it doesn't see it. So keep that in mind. It can be frustrating when you're doing this and it doesn't see the objects, and the objects are a strange shape. So to make things easier when you set up your exercises, you want to try to have shapes that are very flat so that the sound bounces back. Okay, so we did it. We set up the ultrasonic sensor, and we looked at how we could use sounds to indicate which path it's actually moving through. And this becomes very, very important once we start putting motion together and trying to do more sophisticated tasks. Okay, so here's where we are now. In terms of sensors, that is now our second small check. So we are on our way toward actually doing something that's a little bit more complicated. At this point, we know how we have our sensors on our taskbot. We've looked at looping structures and switches with the ultrasonic sensor, and we know how to use those, and we can kind of put it all together with motion now, and we can do a simple thing such as task avoidance when we have motion. So we can use multiple looping structures in order to actually drive along. If it sees an obstacle, stop, turn, and try to go around it. So that will be the next task. So right now, I encourage you to get this program running just as I did, and play around with different distances to the ultrasonic sensor. Play with different play with different objects in front of the sensor and see how some reflect the sound a little bit better than others, and kind of see where the limit is. It allows you to go out to 255 centimeters, but sometimes it's really difficult for the ultrasonic sensor to detect objects that far away. So kind of play around and get familiar with the sensitivity.